All right, today we are cracking open a really interesting project called BDVE. That stands for Bi-Directional Deterministic Vector Embeddings. And we're going to see what it's like to build text embeddings inside a glass box, instead of the usual AI black box. Let's dive right in.
So let me just start with a big question. What if you could pull real meaning out of text and turn it into these useful vectors, but do it all right there on your own computer? I'm talking no fancy GPUs, no paying for API keys, and definitely no relying on some giant company's cloud servers. That's the whole idea we're going to explore.
You see, most modern AI, especially for language, works like a black box. It's incredibly powerful, for sure. We feed it text, and amazing things come out. But what's happening on the inside? It can be a total mystery. These models are expensive to run, and they can be unpredictable, meaning you might not get the exact same result twice. And that's a huge problem if you need results that are verifiable and perfectly reproducible.
And that leads us to this, the alternative. What if we just traded that black box for something completely transparent, something predictable, something deterministic?
And here it is, BDEV. It's a prototype system that runs completely offline. Its job is to turn text into semantic vectors, which are just, numbers that represent meaning. But here's the kicker. It doesn't use a neural network. It's all done with pure, verifiable math. So if you give it the same text, you get the exact same vector every single time.
So let's really make this clear. On one side, you've got the neural black box. It's powerful, it gets deep context, but it's super complex and, unpredictable. On the other side, you have BDV's glass box. Every single step is built on transparent math, linear algebra, and stats. You can audit it, it's lightweight, and it's 100% reproducible.
And this quote from the project's own documentation just says it all, doesn't it? This whole thing is designed to run on a regular laptop, completely disconnected from the world. It is self-contained by design.
Okay, so we've talked about the big idea, but how does this thing actually work? Let's take a look at the pipeline itself and see how you can get it up and running.
Getting started is actually super simple. The project gives you these little install scripts. You just run one file, and bam! It sets up its own little isolated Python bubble. It only needs a couple of standard math libraries like NumPy and SciPy, and that's it. Your main computer is totally untouched.
Now, for all you command line fans out there, you can see the whole shebang with just one command. Right here, we're just telling the tool to run its entire pipeline on the phrase "Hello World." In just a few seconds, it'll break down the text, create the vector, and then even put it back together.
But hey, if the command line isn't your thing, no worries. There's also a full graphical app. You run one script, and this pops up. You can type in whatever you want, click through each step of the process, and literally watch the results build up on screen. It even has this cool heat map that visualizes the final vectors. It's a really great way to get a feel for what's actually going on under the hood.
Okay, so we've seen what it does. Now for the really fun part, how does it do it? How do you get from words to numbers without a giant neural net? Well, it all comes down to a 5-step mathematical pipeline.
The journey from a sentence to a vector follows these 5 clear stages. First, you train a model on some text to build a vocabulary. Then, when you give it your own text, it tokenizes it into smaller pieces. After that, it groups those pieces into chunks. Then comes the magic. It embeds each chunk into a vector. And finally, and this is super cool, the whole process can be reversed, letting you find the original words from just the vector. Let's look at the math that makes a couple of these steps possible.
So we need to go beyond just counting words. If you only count how often words appear near each other, common words will dominate everything. That's where this thing called NPMI comes in. It's a clever statistical trick that fixes this bias. It basically measures how much more likely 2 words are to hang out together than you'd expect by pure chance. It gives you a much cleaner signal of their real relationship.
After that NPMI step, you're left with this huge but mostly empty matrix of word relationships. Truncated SVD is the magic that compresses it all down. You can think of it like taking a giant blurry image and finding the sharpest, most important patterns to create a small, dense thumbnail. That's what creates the final useful vector embeddings in that embed stage. This is why the B in BDVE stands for bi-directional. Because every single step is just math. That reverse step we saw actually works perfectly. You can take any vector the model produces, run a quick calculation, and find the human-readable words it's closest to.
This is amazing. For understanding what the model is thinking, you can actually inspect what a vector means.
So you might be wondering, is this supposed to replace those giant language models? And the answer is not at all. This is all about having the right tool for the right job. So let's look at the trade-offs. As you can see, BDVE really shines when you absolutely need determinism, interpretability, and low cost. Now, a big neural model is going to have a way deeper, more nuanced grasp of context, but that comes at the cost of being a complex, resource-hungry black box. They really are designed to solve different kinds of problems.
So why would you reach for this glass box? Well, maybe you're in a field where you absolutely need to audit and reproduce your results perfectly, like in scientific research or finance. Or maybe you're building something for a device that has no internet and very little power. Or heck, maybe you just want a simple, fast baseline for text analysis without all the crazy overhead. At its heart, this project isn't just a tool, it's really a learning resource. It's inviting you to get your hands dirty and see for yourself how this all clicks together.
So the big takeaway here is that BDVE is a fantastic proof of concept. It's a transparent, mathematically grounded alternative for turning text into vectors. It's a baseline that you can actually understand, inspect, and trust from start to finish.
And that brings us to the end. Honestly, the best way to understand this is to just try it yourself. The source material points you straight to the GitHub repository. You can read the white paper that goes deep into the math, and you can fire up that interactive demo we saw earlier. Go ahead, give it a try. What kind of patterns might you uncover in your own text?